In this clip, we'll be covering net present value, internal rate of return, IRR, and something called modified internal rate of return. And modified internal rate of return, or MIRR, may or may not be something that's going to be covered in the class that you're currently taking. But I do think it's a relevant and an important concept. It's actually a little technique that can be used to solve some of the problems with internal rate of return. So I'm going to go over it quickly at the end of or towards the end of this clip. But again, you may or may not be responsible for the modified internal rate of return. I'm sure for whatever class you're taking, you're going to have to definitely know net present value, NPV, and internal rate of return, IRR. Okay, so the first item here, net present value. Net present value comes from corporate finance, and it's a capital budgeting technique that's been applied to real estate, and it makes a really nice, application, to real estate. And basically, net present value, all it really is, it's very simple. It's just cost benefit analysis or benefit cost analysis. And it's just the present value, the PV, of an investment's benefits minus the present value of the cost of that investment. And that equals basically net present value, NPV. Now, most of the work is done in calculating the present value of the benefits because usually in an investment, the benefits are spread out over different years or different time periods. And so what we have to do is we have to discount those future cash flows. An example we're going to look at, a property we've projected cash flows over a 3-year period for a property, and it costs $15,000 today to invest in that property. Well, right now, I know the present value of my cost. The present value of the cost is in today's dollars. In the example we're going to look at, it's 15,000. Okay, but what we're going to have to do a little work on is calculating the present value of the benefits. And the benefits are down here. And the problem is that they're spread over different years or different time periods. And again, think of different time periods as almost like different currencies. They're in different types of dollars. In year $1, year $2, and year $3. And what we have to do is convert those different currencies or time units into year $0, today's dollars, to get the present value of the benefits. But it's simply, at its root, is just the benefits minus the cost, and that's how we get net present value. We net out the benefits and the cost. Just like your net pay, is net of taxes, well, a net present value is the present value of the benefits net of the initial cost. Okay, so let's go right down to the example. And the example is, what is the present value of the following series of annual cash flows that occur at the end of each year? Use a 10% discount rate, so good old 10% discount rate, and assume that the investor paid $15,000 for the rights to receive these cash flows. And then there we have the cash flows. In year 1, it's 5,000. Year 2, it's 7,500. And year 3, it's 6,000. So what we have to do is simply discount those cash flows back to present value. Now, because the cash flows are not even, we can't use the present value of an annuity function. Okay, if they were 5,000 for year 1, 2, and 3, we could just take the present value of an annuity. But these are uneven cash flows. So what we could do, we have a couple of choices. I think we're going to find out quickly that the quickest choice is to use the cash flow menu on the calculator. But before we do that, what we could do is just discount each cash flow back by using our present value formula. Present value equals future value divided by 1 plus I to the n. And go ahead and try this for each of the cash flows. Take 5,000 divided by 1 plus I, or 1.1 in this case, because we have a 10% interest rate, to the n, to the first power, and you should get $4,545.46. And then for year 2, take 1.1 and raise it to what power? Correct. N is 2, so raise it to the second power, and you should get $6,196.35, or very close to it. There could be some rounding. And then for year 3, just take, again, 1.1 and raise it to what power? What's n? 3, okay? To the third power, or cube it. And that's $4,507.89. And then sum those up, just add them all together, and that should total $15,251.70. So that's the first way we could do it. We could just use the present value of a lump sum formula and treat each of these cash flows as a discounting problem, discounting each cash flow back individually as one lump sum to present value. Well, a little quicker might be our calculator, and we could use our time value of money menu to solve this problem. But again, we'd have to treat the cash flows as a series of lump sum individual, one event cash flows. So for year 1, what we could do is we can discount that back 1 year. Let me put the time value of money menu up here. N, interest percent, PV, and we're going to be solving for PV. Payment's going to be empty or 0, and future value is going to be the cash flow. Okay, so in each case we're going to solve for PV. N is going to be 10, and for year 1, N is going to be 1. And what you do is you put in the 5,000 into future value and hit PV, and you should get $4,545.46, or again, very close to it. For year 2, you're just going to put 2 into N, keep 10% in I, solve or compute for PV, make sure your payment is empty or clear, and put 7,500 into future value. And you should get $6,196.35. For year 3, okay, just put N into 3 now. Make sure I is still 10. We're going to solve or compute PV, make sure payment's empty or 0, and put 6,000 into future value. And you should get $4,507.89. Once again, though, you have to sum up the cash flows, you have to total them, but the sum should be about $15,251.70. So still a little bit tedious, even though we're using the calculator. Now, this type of problem is where the cash flow menu comes in handy on your calculators. And again, even a basic financial calculator should have a cash flow menu. And again, you need to figure out on your calculator how to work your own cash flow menu. But it's basically the menu. You're going to be looking for something. It's going to ask for like a CFO, which is the cash flow in year 0. And for this problem so far, what we're going to do is we're going to put 0 into CFO. So find your calculator cash flow menu. Most calculators ask for the first cash flow. They ask for something like CF0. And that's the cash flow, the initial investment, the cash flow in year 0 today. And what we're going to do to calculate this table right here, we're going to put 0 in there for now. Later, we're going to put the investment of negative $15,000 in there to do the net present value calculation. But right now, we're just finding the present value of the benefits, the present value of the cash flows. All right, and then enter that or input that. You might have to scroll down to the next cash flow. Before you did this, I should mention, make sure your cash flow menu is empty. So you might want to clear out your cash flow menu and then go to CF0 and put in 0, just to make sure there's no straggling cash flows left in that menu. That's another thing that could go wrong on an exam, or students have problems with, is stuff left over, just like in the time value of money menu. Things could be left over in these cash flow menus. So every time you start a problem, you want to wipe it. You want to make sure all the registers are clear it out. But find CF1, and CF1 is going to be the first cash flow of 5,000. Okay, when you input that, the calculator might ask you how many times. Okay, do you want to enter that cash flow of 5,000? And this would be useful if maybe for the first, 3 years, we were getting a cash flow of 5,000, and then after that, the cash flow was estimated to go up to 6,000, and we had step ups over a long period of time. And for those types of problems, that times option or menu or function is very useful. But it's kind of a pain for our short little problem with different cash flows each year. So when it asks you for the number of cash flows for cash flow number one or the times, just leave it at one because it's a one-time occurrence. It's going to be $5,000 in year one, and that's it. Then go to cash flow number two and enter cash flow number two, 7,500. Okay, and again, when you input it, the calculator is going to ask for the number of times, or and it's just going to be one. Okay, so just leave it at one again. We have 7,500 in year two, and that's it. Cash flow number three, put in your 6,000 for cash flow number three. And again, when you input it and it asks for the number of times, just leave it as the default of one. Okay, well the next step, whenever we calculate a present value, we need to enter an interest rate, the discount rate. We can't discount things without a discount rate. And our problem gives us a discount rate of 10%, but we got to tell the calculator that it's 10%. So what you need to do next is find out on your calculator how you enter I, the interest rate for the cash flow menu. For my HP, what I have to do is I have to exit out of that cash flow menu, and then I see options to enter I. Okay, and enter I, which in this case is the proper name for it, is our discount rate, and it does ask I as a percentage. Okay, so I'm going to put in 10 for 10%, and then not far from my I key is my net present value key. Okay, NPV key. And I'm going to go ahead and hit my NPV key, and you should get the sum of $15,251.70. If you didn't get that, why don't you pause the tape, go back to the drawing board, and try it again with your calculator. But you should get when you hit NPV, you should get $15,251.70. Now, is this technically a net present value? No, we haven't netted the benefits against the cost yet, so it's just a present value. So what we did is we used the NPV key to calculate the present value of the benefits. We haven't netted anything out yet. So, technically that label is wrong on the calculator, or we're using the NPV function for something, that's not, normally used for. But we do use it a lot for just calculating the present value of any uneven cash flows. Okay, well the next step is to do the netting. And basically what we're going to do is we're going to net out the present value of the benefits against the cost. And here we do it right, right in the text. We can just take $15,251.70 minus the present value of the cost, or the investment of $15,000, and that nets out to be $251.70. Now that is our NPV. Okay, the right label for that number is net present value, because we did net it against the cost. And that's why it's, this NPV is just simply cost benefit analysis. Okay, pretty simple. So what we have here is the present value of the benefits. What we have here is the present value of the cost, or the initial investment. And we just net those two numbers out. And NPV equals $251.70. Okay, the decision rule for NPV, okay, the classic decision rule for NPV is that whenever NPV is positive, okay, we invest. Because when NPV is positive, that means that we're achieving a return, an internal rate of return, which we'll talk about next, greater than our discount rate. So if our discount rate is 10% and our NPV is positive, now we haven't calculated the internal rate of return yet, but I know from the relationship between internal rate of return and net present value that my internal rate of return is going to be greater than 10%. Okay? However, when NPV is negative, we reject. We do not invest, because that tells me that the present value of the benefits is less than the present value of the cost, and we have a negative NPV. And in relationship to the IRR, that means our internal rate of return, the actual return on that investment, is less than our discount rate. So I know if our NPV was negative, that our actual rate of return on that investment would be something less than 10% in this example. But we had a positive NPV in this example, didn't we? So that tells me that the present value of the cost of the benefits, I'm sorry, the present value of the benefits are greater than the present value of the cost. And in that case, we should invest in that potential investment. Okay, so that's the basic classic decision rule for net present value. Again, going back to our calculators, okay, hopefully you still have those cash flows in your menu. If you go back to cash flow 0 or cash flow O and put in negative 15,000 this time, you might double check to make sure cash flow 1 is still 5,000, cash flow 2 is still 7,500, cash flow 3 is 6,000, and you still have the 10% interest or discount rate inputted into the calculator. If you hit NPV a second time, you should get the $251.70, because the calculator this time is going to subtract anything. Well, you're going to tell it to subtract by putting it in as a negative, but it's going to subtract the CFO from the present value of the total benefits to net out the benefits and the cost to give us a true net present value. So if you do enter the cash flow 0 as negative 15,000, hit NPV, you are this time truly getting a net present value, Okay. Well, I already mentioned internal rate of return a little bit back there, so let's talk about it formally here. But the IRR, the internal rate of return, and we often just refer to it as IRR, and that's how it's referred to on your calculator keys, if you notice, is the actual rate of return that we achieve on our investment on a series of cash flows. And down below we have a series of cash flows. Again, we have a 4-year investment, and we have cash flows each of those years. And we could try to do NPV, or internal rate of return, by hand. Okay, it's very difficult because it's an iterative process. It's basically using different interest rates, okay, to achieve a net present value that's equal to 0, or balance out the present value of the benefits and the present value of the cost. Achieve the discount rate or the interest rate that makes the present value of the benefits equal to the present value of the cost, and that results with an NPV, a net present value, of exactly 0. So another way of thinking about internal rate of return is the one special discount rate. Okay, we could use any discount rate, but the internal rate of return is the one special discount rate that makes the present value of the benefits equal to the present value of the cost exactly, which again results in an NPV of exactly 0. So the IRR is the discount rate that makes NPV equal to 0. So this table, we do try to look at estimating net present value by maybe using different discount rates and looking at what the NPV is. And the closer we get to 0, we look at what discount rate we're using, and the one we can get closest, make net present value closest to 0, that's what we're going to call the internal rate of return. Now, although we're going to look at this as an example, we never do this in practice. How we usually calculate internal rate of return, again, is with our cash flow menu on our calculators, and we let the calculator do this process because the calculator is a lot quicker than we are in plugging in numbers and crunching math. But to look at the cash flows here, what we have going on, again, we have 4 cash flows. Okay, this does look a lot like a real estate investment. You'll notice that the first 3 cash flows are 9,000, 9,500, 12,000. The fourth one is 118,000. And we invest, okay, we invest in year 0 100,000. And what is probably going on in the 4th year is that we're estimating the sale of the property or the investment, and we're going to sell the property for 100,000 maybe, and we're going to have 18,000 of income. So that's my guess. So it looks like a typical real estate investment. You pay 100,000 for it, you rent out the property for 4 years, collect some cash flow and some income, and then you sell the property at the end of the 4th year. And at the end of the 4th year, you actually have 2 cash flows: the cash flow from the sale of the property, and the actual annual cash flow from the rental income. And what we've done here is we've discounted each of these 4 cash flows to present value, again, either using the formula or your calculator, or most preferably your cash flow menu. And this would be good practice for you on your cash flow menus. So what I'd like you to do now is stop the tape and see if you can calculate or crunch the numbers here with your cash flow menu and get 105,645 at a 10% discount rate. And you should be able to recreate that. And then what I'd like you to do is crunch the numbers again using a 15% discount rate, the same cash flows, okay, but again, just using a different discount rate. And the present value, okay, these are the present value of the benefits at 2 different discount rates, 10% and 15%. And you'll notice, um, one is higher than our initial investment of 100,000, and discounted at a 15% discount rate, we're lower than our initial investment of 100,000. So if we take the present value of the benefits minus the initial investment, you'll notice that at a 10% discount rate, we have a positive NPV, right? So if you take 105,645, subtract out the initial investment to calculate the net present value, we have $5,645 left over. Or just to kind of summarize that, we have a positive net present value. However, if you take 90,366 minus our initial investment of 100,000, okay, that nets out to negative $9,634. But to summarize, I'll just say we have a negative NPV. So what can you tell me about the internal rate of return without doing the calculation yet? What range does it fall within? Well, we know it has to fall within the range of 10 to 15%. So this is how we could hone in on what the actual internal rate of return is. Just use different discount rates and basically select the rate that's close, the discount rate that produces the net present value that's equal to 0. Okay, so it's definitely between 10 and 15%. Kind of eyeballing it a little bit. It might be somewhere around 11.5 to 12%. Okay. Again, what we're going to do is use our calculator to solve for the exact internal rate of return. The example here does a little extrapolation example, but why extrapolate when we can calculate it exactly on our calculators? So again, go back to your cash flow menu, clear out the cash flow menu. We have different numbers now, and this time for cash flow 0, make sure you put in negative. It's got to be negative. Our initial investment is $100,000. That's money out of our pocket. That's a negative. So put in a negative 100,000. Okay, scroll down or go to cash flow number 1. And cash flow number 1 again was 9,000. So put in 9,000 for cash flow number 1. Number of times, just one time, one occurrence. Cash flow number 2 is 9,500, and again that's positive, right? That's money coming into our pocket, just like cash flow number 1. Cash flow number 3, okay, that was 12,000, and again that's a positive. That's money flowing into us. And cash flow number 4 was the big one, right? It was maybe the return of the investment when we sold the property, and also the cash flow for the 4th period, and that was 118,000, and again that's positive. So we have our negative cash flow, our investment to get into this, asset, to buy this asset, the property, or it could be a, stock or a bond. We have our cash flows for each of the periods, and then finally we need to enter the discount rate. Or no, I'm sorry, we don't enter a discount rate when we're doing internal rate of return. Absolutely not, because we're trying to find the discount rate that makes the NPV equal to 0. So that was just a trick to make you remember that when you enter internal rate of return, you don't need to enter a discount rate. You could, okay, but the computer is going to ignore it in its calculation, because what the calculator is trying to find is that's trying to find a discount rate, the discount rate that makes the NPV equal to 0. So what you do next is find your internal rate of return key on your calculator, and go ahead and compute or hit IRR, and you should get, okay, 11.73%. That should be the internal rate of return. All right. And the relationship between internal rate of return and net present value, let's write it out formally. We've already talked about it, but when NPV is positive, okay, what can you tell me about internal rate of return in relationship to the discount rate? Well, when NPV is positive, we know the internal rate of return is greater than or less than the discount rate. When NPV is positive, the internal rate of return, the actual return on that investment, on those cash flows, is greater than the discount rate used to calculate the net present value. When NPV is negative, okay, when we have a negative net present value, what can you tell me about the relationship between the internal rate of return and the discount rate again? Okay, yeah, the internal rate of return, the actual rate of return, is less than the discount rate. And then finally, okay, there could be a third option, right? The third option, what if NPV is exactly 0? Okay, it's exactly 0. What can you tell me about the relationship between internal rate of return and the discount rate? And this is the big question here, okay? I'm hoping no one gets this wrong. What can you tell me between the relationship between the internal rate of return and the discount rate? Greater than, less than? No, right? It's equal. Okay, you found the discount rate that is the internal rate of return when NPV is exactly 0. All right, so you found the IRR. Well, good. Well, after talking about internal rate of return and doing the calculations, I think it is also important to note and mention here that there are several problems with the internal rate of return as a return measure. And we'll talk about and beat up the internal rate of return a little bit here. But I don't mean to beat it up too much, because internal rate of return is very important and used quite a bit. If you ask an investor what kind of return did you get on your real estate investment or your stock portfolio or your bond portfolio, they're probably not going to give you a dollar amount. They're probably going to tell you, I made a 12% return, I made a 25% return. So investors love to speak in terms of returns. So internal rate of return is used quite a bit and is very important. But one of the problems with it is the scale problem. Okay, scale. So I'm going to write scale next to this, the first problem here, because that summarizes it quite nicely. In fact, what we could do is we could start a column even. On the left, we'll summarize the problem, but we have fixes to these problems, or things that we can do to solve these problems. And over on the right hand side, I'll put the solution. So the first problem is the scale problem, that internal rate of return is insensitive to the investment scale. And a good example here is, suppose you ask someone whether you would like a 20% return on an investment or a 100% return. So I'll give you, you don't have to put any money in. I'm going to give you two deals, okay? One deal, you'll make a 20% return. One deal, you make a 100% return. Which deal would you select? Well, of course, everybody would select the 100% return, but I didn't tell you all the information on these two deals, okay? Let's say that the first deal, or the second deal, the 100% return deal, was that I'll invest $1 for you, and this dollar will make a 100% return. At the end of the year, it's going to grow to $2. And I think there's a typo there. I think that's supposed to be 20%, not 205. Whereas the 20% investment, what I'll do is I'll invest $1,000 for you, and at the end of the year, you'll get back 1,200 at the end of the year. So you get to keep $200. And in the first example, you only get to keep the the increase of a dollar. So by choosing the 20% deal, you're much better off, right? Okay, so you'd actually make a lot more money. You'd be a lot more wealthier, um, with the 20% increase investment increase deal, because of the scale of the investment. It's a much larger investment. You're creating more dollars with a 20% return than the 100% return with only a dollar investment. So you're creating more wealth. And for this reason, that's why NPV, net present value, is considered to be a better measure of return, because it measures the actual wealth increase in absolute dollars, not percentages, because percentages can be misleading, okay? And in this case, the 20% return was much better, created much more wealth than the 100% return. So I'm going to put over here the solution is NPV. But again, if you talk to the typical investor about what's their return last year on their portfolio, they're usually going to quote you a rate of return, not I've made $745,892.32. I made a 12% return. Okay, number two. Okay, internal rate of return tells us nothing about the risk of the investment. It's not a measure of risk. And this criticism also applies to net present value. But again, let's use an example to try to explain this. Let's say we have two investments, and both investments would require an investment, a cash flow year zero, or an investment amount of 100,000. And this would also be good practice on your calculators, on your cash flow menu. If you want to enter these into your cash flow menu and calculate the internal rate of return for both of these investments, that would be good practice. You could pause the tape now and enter cash flow 1, 8,000 for the first investment, cash flow 2 of 11,000 for the first investment, cash flow 3 of 12,000 for the first investment, cash flow 4, CF4 of 13,300 for the first investment, and cash flow 5 of 125,000 for the first investment. Go ahead and hit internal rate of return, compute internal rate of return, And you should see that the IRR on this investment is 13%. Okay. On the second investment, why don't you clear your cash flow menu, put $100,000 negative, remember it has to be a negative, into cash flow 0, year 0. For cash flow 1, put in 1,000. Cash flow 2, 1,500. Cash flow 3, 400. Cash flow 4, 2,200. And cash flow 5, 177,460. And go ahead and compute internal rate of return again, and you'll see that this investment also produces a 13% internal rate of return. So we have two investments. They cost the same amount of money to invest in, and they both achieve a 13% internal rate of return. But if you look carefully at the cash flows, one of these investments appears to be maybe much riskier than the second investment. Which investment would be more risky looking at the cash flows? Well, one of the tenets of finance is that we prefer to get money, investment, dollars, earlier rather than later. Again, because receiving money, further out into the future is more risky. And we have the time value of money working against us, and also, other practical things like, sometimes, people don't pay their rents, investment deals go bad and the cash flows never appear, especially the further out the cash flows are, the more risky, or the more risk that something might happen, and those cash flows might not actually be received or achieved. So based on that logic, which investment is riskier? Well, it looks like cash flow number 2 is riskier. Look, compared to cash flow number 1, where you're receiving a lot of the cash flow early in the investment period, years 1, 2, and 3. And in cash flow number 2, you're achieving very little of the dollar return in cash flow number 2. And you can see most of your cash flow is coming at the very end of the investment. So a lot of the cash flow isn't received until year 5, till the very end of the investment period. So given this choice of investing in either investment number 1 or number 2, they both have the same internal rate of return, I would definitely prefer investment number 1, because I get my money back a lot quicker, a lot earlier than investment number 2. So that's to summarize this problem, we can say something like, does not evaluate risk well, okay? IRR is not a measure of risk. The solution, we are going to talk about something not in this clip, but one of the future clips, a calculation called duration. And duration is a measure of when the cash flow is received. It's a time-weighted measure of return. And we'll do some quick examples of duration. Okay, the third problem with the internal rate of return calculation, we can kind of summarize as the reinvestment assumption. Reinvestment assumption or problem. Because what the internal rate of return calculation assumes is that all the cash flows that are received, maybe going back and looking at the problem above, is that all these cash flows that are received in years 1, 2, 3, 4, and ultimately 5, that these cash flows are reinvested immediately at the internal rate of return. Okay, so that means that when you receive $8,000 in year 1 from investment number 1, that immediately this $8,000 is invested at the internal rate of return. It's put in some account that's generating a 13% return. Same thing with cash flow number 2 of $11,000. That this cash flow, immediately upon being received in year 2, is invested at a 13% rate for the remaining years 3, 4, and 5. For cash flow number 3, It's assumed that the $12,000 received is immediately invested at a 13% return for years 4 and 5 until the end of the end of the investment period. So this might not be very realistic because what we might be doing with these cash flows is maybe maybe we're putting them in a money market account. Maybe this is a real estate investment and these are our annual cash flows, and what we do at the end of the year is maybe we put them in a safe account, like a money market account, and maybe that account's generating 4% return. And what we're doing is we're trying to accumulate money, and then someday we're going to invest that money at another property that might generate 13%. But until we accumulate enough money, we're going to be putting it in our safe account, our money market account, and it's not going to make a 13% return. So if that's true, we're not actually going to generate or receive a 13% internal rate of return because we're investing those cash flows at a lower rate. Our actual realized internal rate of return is going to be something lower than 13%. To achieve that 13% internal rate of return, we'd have to reinvest all those cash flows exactly at a 13% return immediately for the remainder of the investment period. So that's a bit of a problem. But there's something that we could do to try to solve this problem, and that's the modified internal rate of return, or the MIRR. And we'll talk about that next here. Another problem with the internal rate of return is that it has problems with negative cash flow patterns after the initial investment. The initial investment, year 0, usually always a negative investment. Okay, I have to invest so much to buy a property, stock, or a bond. So the CFO is always negative. But what could happen is that sometimes some of the future cash flows might be negative too. So in this example, if one of the cash flows in investment 1, let's say the year 3 cash flow was a negative 12,000, well, what's going to happen is that mathematically there's actually going to be 2 routes or 2 IRRs to solve this problem, okay, with a negative future cash flow. And we really don't know what the true IRR is. The calculator might spit out an IRR, but it's not technically necessarily the correct IRR because mathematically there's 2 solutions to that problem. So the IRR kind of breaks down or kind of fails when we have negative future cash flows. And this is a problem with real estate investments because lots of real estate investments do or might have future negative cash flows. Maybe in year 3 we need to replace the roof and renovate, remodel. So we're going to reinvest a lot of capital into the property, and we're going to have a negative $12,000 cash flow. That could definitely happen, especially in a real estate investment. So that's why, again, something called the MIRR, the modified internal rate of return, is quite useful in real estate analysis because the modified internal rate of return can handle future negative cash flows. And the way it handles it, which is a good lead in here, okay, it will show you. So the next section is the modified internal rate of return. And again, this might be optional for some of you in some of your classes and sections. So if you don't want to learn about it, you can turn off the tape if you don't need to know it, but I think it's pretty useful stuff. So I will go over it. Now, with the modified internal rate of return, what we're going to do, okay, and again, it's going to solve the multiple solution problem and also address the reinvestment rate problem of the internal rate of return. And what we're going to do, we do have to make another assumption. We're going to have to assume, or we have to know what our reinvestment rate is, and also what we'll call our safe rate is, okay, or our cost of funding of the negative cash flows. So it does require estimating a different rate than just one discount rate. So now we have 2 rates, and one rate is our cost of funding that we're going to calculate the present value of our negative cash flows. And then the other rate is kind of our reinvestment rate, where we're going to compound out to the future our positive cash flows. at the second rate. Okay, and so for the modified internal rate of return, we're not going to be using our cash flow menu at all. What we're going to be doing is either discounting or compounding, depending on whether the cash flow is negative or positive, and we're going to calculate a total present value and a total future value, and the modified internal rate of return is going to be the interest rate, okay, or the internal rate of return that makes the present value of the benefits and the future value, the future value of the benefits and the present value of the cost equal to 0 over the holding period. So in this problem, and again, probably the best way to understand this and learn this is try a problem. In this problem, we're going to assume a safe rate of 6% for discounting the negative cash flows to present value to year 0, and a 9% investment or reinvestment rate for the compounding of the positive cash flows. And here we have an investment with both positive and negative cash flows. Again, the year 0 cash flow, that's expected to be negative. In year 1, we have positive cash flow of 10,000. And what we're going to do is we're going to take this cash flow and we're going to compound it to the end of the investment period, at the end of the 5th year, at the 9% investment or reinvestment rate. But year 2, we have a negative $15,000 cash flow. Okay, so it's not a positive cash flow. We actually have to put back in 15,000, or we lose 15,000 that year. What we're going to do here is we're going to discount this cash flow back to year 0, back to the start of the investment, back to present value, at our safe rate of 6%. Okay, and then year 3, we have a positive $18,000 cash flow. And once again, we're going to take the positive cash flows, we're going to say we're going to put them in an account, we're going to reinvest them, and our assumption here is the reinvestment rate of 9%. And then year 4, we have another negative cash flow. And what we need to do is we need to discount that negative cash flow back to year 0, again, at our 6% discount rate. And we're going to discount it 1, 2, 3, 4 periods. And then finally, in the 5th year, we have our positive cash flow at the end, and that's just going to be added as part of our future value, just like the negative 100,000 is just part of our year 0 investment. Now, what we could do, okay, again, we could do this using formulas, our present value, future value formulas, and remember the present value of a lump sum is just the future value divided by 1 plus I to the nth power. So to calculate, to discount the negative cash flows back to year 0, okay, we could treat it like a series of individual present value discounting problems of lump sums. And if we did that mathematically, we could write it out as a present value, okay, of the, say, the positive cash flows. And don't forget our discount rate is 6%. I'm going to try to write as neat as possible here. We might start out with the year 0, okay, negative 100,000, and that is in present dollars, that is present value. So I don't need to discount it by anything. And I'm going to add to that the negative 15,000 discounted (1 plus 0.06) to the what power? How many periods do I need to discount the 15,000 back to get it to year 0? Well, it'd be 2. It'd be 1, 2. So I'm going to raise that to the second power, just that denominator. Okay, and notice that's a negative sign, so it's going to be 100,000 minus something here, 15,000 discounted, which should be 13,350. and then plus, again, want to emphasize that's a negative 22,000. That's our year 4 cash flow. And that's discounted at our safe rate of 0.06, 1 plus 0.06. And what power do I raise it to? Well, just count the number of periods you need to discount back. 1, 2, 3, 4. So I'm going to raise that to the 4th power. Okay, and if you crunch the numbers and add those up, you should get negative 130,776. Okay, which is what we found here. To compound the positive cash flows to the end of the investment period, again, I could write that out mathematically. We're going to take the future value of the cash flows, and don't forget we have another rate. We got the 9% reinvestment rate. And our first positive cash flow is year 1. We have $10,000. And I'm going to just multiply that times 0.109 for how many compounding periods? Well, again, we're going to take it all the way out to the end of year 5, so it's going to be 1, 2, 3, 4. It's going to be 4 compounding periods. So I'm going to raise it to the 4th power. Our next positive cash flow is in year 3, and that's $18,000. And I'm going to multiply that times 0.109 to what power? Well, again, count how many compounding periods you have. You have 4 and 5. You have 2 compounding periods left. So I'm going to raise it to the 2nd power. And then you add the cash flow at the end of year 5 of 185,000. And that doesn't need to be compounded because it's already at the end of the investment. So it's already in end of year $5. So there's no compounding necessary. And if you do the number crunching, that should total to 220,502. Okay, hopefully it's very close to 220,502, which is the number we got here. So in this table, what we did is we either used the formulas, or maybe we used our calculator and just treated these as a series of lump sum discounting problems. Or compounding problems, and calculated the present value of the future value for all the cash flows and just sum them up. Okay. So now all the cash flows have been kind of summarized or reduced to one large negative cash flow at the beginning of the investment period and one large positive cash flow at the end of the investment period. And then the last step is just to use our time value of money menu on our calculators to find the interest rate that makes these equal. Okay, that makes the present value of the negative cash flows equal to the future value of the positive cash flows. And again, go to our calculator time value of money menu. You want to clear it. You want to make sure you're set on 1 payment per year. You want to make sure you're in end mode, END, not beginning mode, BEG or BNG. We're going to be solving for I, okay, which is actually the modified internal rate of return in this case. And then plug in what you know. And you do have to watch the signs, okay? N is 5. We're dealing with a 5-year holding period. The PV is going to be a negative, okay? I want to emphasize that. The PV is going to be negative 130,776. make sure payment is empty or put 0 in it, just to verify. And your future value is going to be positive, right? Positive 220,502. And then if you hit I, the calculator might take a brief second to crunch the numbers, but you should get about 11.01%. And that's your modified internal rate of return. Okay, so with the modified internal rate of return, there's only one solution. We were able to handle negative future cash flows with it, and we were also able to specify different rates. A rate for compounding, you can think of that as the reinvestment rate that you can reinvest your positive cash flows, and also a safe rate. Sometimes it's called a safe rate, that you discount the negative cash flows back to present value. All right, well, this clip's getting kind of long, so I think I'm going to stop here, and we're going to move to problem set number 2 if you're following along the schedule here. Okay, so try problem set number 2 before starting the next clip. Signing off.